Good morning, one and all. Today we discuss about 12th chapter, that is dual nature of radiation and matter. Dual nature of radiation and matter. Okay, what is the dual nature? Means wave nature and as a particle nature. Both are same properties. That is the matter waves or particle nature. That is radiation. Electromagnetic wave radiation means electric field and magnetic field gives the electric magnetic radiation. That is radiation field, electric field and magnetic particles and waves are both nature. That is the dual nature of the both having same properties in this chapter. Okay, now we discuss in the chapter. Now we discuss emission of electrons. That is in the chapter we main are electron emission, photoelectric effect, photoelectric effect. Third one is Einstein explanation. Fourth one is particle nature of light and matter waves. These are the important topics in the dual nature of the radiation and matters. Okay, now we can explain in this chapter electron emission. Okay, we can choose the one metal. In this metal, the number of free electrons, that is positive charge carriers or negative charge carriers. That is positive charge carriers, that is electron, okay, is there. Okay, and also positive charge carriers metals like this big. It is positive charge carriers, positive. It is positive charge carriers. Some electrons is there in the metals. Number of free electrons is there, that is they gives high conductivity, high current. This type of metals is called conductors, or metals or conductors are the both are same. Okay, how to emit the electron from the metal surface? Okay, suppose in the case of metal, some nucleus is there. Nucleus around k orbitals is there, sp,d orbitals. This nucleus sp, d, f like this orbitals is there in the nucleus. This first orbital we cannot move the electron. That is in between the around the nucleus first orbital, it have strong attraction force in between the nucleus and particles. In the second orbital, compared to first one, that means from the nucleus to increasing the radius, the attraction force will be decreases. That means at outermost orbital, long distance, it is we want to remove the electron from the outermost orbital, move easily. That means it is very away from the nucleus. That is near the nucleus we we can't remove the electrons or any anion. But in the case of outermost orbital, that is it is higher distance from the nucleus, it can be remove the electron from the nucleus. That is a metal or any lithium, potassium, magnesium, any atom, we can remove the electron from the outermost orbital easily. That means it is attraction force is very less compared to first orbital. It is last orbital, that is outermost orbital. Okay, we can choose metal in this way, but we can't move electrons from the metal without any external force. But it is not direct. That is electron cannot move metal directly. That is the we can apply the external source, that is anyone, electric radiation, magnetic radiation, light, so anyone that is can observe the energy, it can remove the electrons. Okay, that is the electron emission. How to emit the electron from the metals? Okay, in this case the positive charge carriers and negative charge carriers are between the, what is the difference between the electron is the negative charge carriers, positive, negative. That means it means in between attraction force is there. In case positive, negative, that is in between negative, negative is the negative charge carriers, positive negative charge carriers and positive charge carriers. In between them, the attraction force will be appear. Attraction force. That force is attraction force F is equal to K is the volume constant, K Q1 Q2 by R square. That is the attraction force between the two charge carriers. That is one is Q1 charge carrier, that is positive charge, that is negative charge, that is Q2. Okay, there is a negative charge and positive charge. In between the, that is the radius. In between them, the radius is there. The attraction force in between the two charge carriers, that is the F is equal to K Q1 Q2 by R square. This is the that is the attraction force. That is attraction force in between the two charge carriers. Okay, it is attraction force is more, we can't move the electron from the metal surface. That is attraction force is very weak, we can remove the electron from the metal, from the charge carriers, we can remove the, that means break the bond, we can remove the break, it can be remove the easily from the metal surface. That means very strong attraction force is very less means suppose distance is very short distance, Q1 Q2 are very short distance, we can't remove. Large distance, that is attraction force is very weak, very large distance force is weak. That way the charges can be removed, the electron can be easily removed from the metal surface. That is the attraction force in between the two charge carriers. Okay, that is and also here potential energy also is important parameter to remove the electron from the metal surface. That is potential energy is equal to K Q1 Q2 by R. This is the potential energy, this is the attraction force. Okay, suppose we remove the electrons from the metal surface without any external force, we can't move electron from the metal surface. Without any external force, we can't remove the electrons. That is the main reason is in between the two charge carriers, the attraction force is very large. That is attraction force means in the positive charge and negative charge, there will be attraction to each other. That is the attraction force in between the two charge carriers is F is equal to K Q1 Q2 by R square. And also we get potential energy in between the two charge carriers, that is U is equal to K Q1 Q2 by R. That is the attraction force, it is the potential energy in between the two charge carriers. That is why we can't remove the electron from the metal surface without any external work or external force. That is the reason. Okay, suppose we want to remove the electron from this metal surface, that is the minimum amount of electron to remove the electron from the metal surface. This is called work function. When remove the electron from the metal surface with applying, suppose this is metal, positive charge, that is electron. Suppose it is attraction force is there, we want to remove the electron from the metal surface outside. Okay, we can apply the external force, or we want to apply the external force or external field, the electron can be come to outside from the nucleus. Okay, nucleus electron can be comes to outside with applying some strong magnetic field or external field, any field, magnetic field or source, anything we can apply the external source, the electron come to outside. that is the appear in the metal. Okay, this is the what is the how much energy is required to remove the electron. That is the minimum amount of energy is required to remove the electron from the metal surface is called work function. That is work function. Work function is denoted by pi. That is the what is the work function means the minimum amount of energy is required to remove the electron from the metal surface is called work function. It is denoted by pi. What is the work function? Work function means we want to remove the electron from the metal surface, want to apply some external force or external work. That is the work in the form, that is the work, it is called work function. Okay, one is a parameter, that is the work function is one parameter that we want to remove the electron. That is how much out. What is the work function? The minimum amount of energy is required to remove the electron from the metal surface is called work function. Okay, we want to remove the electron from the metal surface, the minimum energy, how much I don't know, that is depends upon nature of the material. Okay, suppose we can take lithium L plus, magnesium plus 3, that means it is outermost orbital is very, this outermost orbital 3. In the case of lithium only one orbital, it is nucleus, around the nucleus, it is away from the nucleus. That is the we want to remove the electron from the magnesium, that is valence electron state is 3 plus 3 means it is outermost orbital 3 electrons is there, only one electron is there in the case of lithium. That is the we want to remove the electron from the lithium, we want to apply more external work. In this magnesium we want to apply the external work only normal or average. That is the main reason. That means it is away from the nucleus, it is nearest to the nucleus. In the nearest to the nucleus, it is attraction force is more compared to magnesium. Okay, this is the work function of in the metal. The work function is depends upon nature of the metal. That means the nature of the metal means lithium, magnesium, suppose copper, Cu+2, copper, okay, aluminium. Okay, that means it is depends upon outermost orbital, that is depends upon attraction forces. Okay, so in the case of chemicals, some attraction force is a repulsion force, attraction force, chemical bond, ionic bond, like this. That means we want to remove the electron from the outermost orbitals. It is suppose we can nearest to the nucleus we can't remove. Okay, we want to remove, but we want to apply external work is more. We want to remove the nearest to the nucleus particles, remove the particle nature electrons, we want to apply more work done here. Suppose we can, in the case of magnesium, less work done, that means it is away from the Mg, electrons are in the away from the nucleus. That is the main reason. That is it is work function is depends upon what? It is depends upon nature of particle. Nature of particles are metals. Okay, particles are metals. Okay, work function pi. It is depends on nature of the particles or metals. Next, second one is types of metal. Types of metal, that means copper, zinc, lithium, like this. Nature of metal. Nature of metal, some metals having weak, some metals are strong. That is nature of particles or nature of metals. And also types of metal. Types of means aluminium, copper, zinc, alkali, alkaline, rare earth metals, like this. That is types of metals. Next, third one is temperature. temperature. Okay, this is a three parameters depends upon work function. Suppose temperature, we can apply the temperature. Suppose we take lithium Li plus 1. Okay, we want it to up to 1200 centigrade, up to 1000. The electron cannot move. Okay, up to 12 centigrade, the electron remove the come outside from the nucleus. That is the reason. Means up to certain temperature, the electron cannot move. That is, it is bond length is very strong between the nucleus to electron. That is in the case of lithium. That is, it is depends upon temperature. Temperature increases means bonds in between the nucleus and electrons will be disappear or broken. Okay, when the bond is broken, the electrons come outside. This is the main parameters of the work function. Depends upon nature of the particle or metal, types of the metal, temperature of the particles. That is the main reason. That is the electron emission. How to emit the electrons from the metals. This is depends upon nature of the particles, types of the metal, and temperature. Okay, now this emission of electrons depends upon these parameters is divided into three types. The emission of electrons, according to these natures, the emission of electrons is three types. That is, one is thermonic emission. Thermonic emission. Second one is field emission. Third one is photoelectric emission. These are the in this three. This is the important photoelectric emission. How to this is how to emit the electron from the metal. That is depends upon nature of the particle, types of the metal, and temperature of the metal or material. Okay, these are the parameters of the work function. What is the work function? Means the minimum amount of energy is required to remove the electron from the metal surface. That is the main thing is electron emission. Means we want to remove the electron from the metal surface. Okay, according to this is depends on these types. The emission of electrons can be divided into three types. That is, one is thermonic emission, the second one is field emission, third one is photoelectric emission. Okay, now we discuss thermonic emission. First one is thermonic emission. Thermonic emission. Suppose we can take one metal like this. It can be connected to the battery. This is negative terminus, it is positive terminus. The current flow is this direction. Okay, when a current is passed through the metal filament heated, the electrons are ejected or emitted. These are electrons are ejected. Suppose current is passing through the filament. The filament can be heated up to 2500 to 3000 Kelvin. Okay, up to 2500 3000 the elements having no electron emission. Up to 2000 or 3000 the electron cannot move from the filament. Okay, after 2000 temperature, 3000 temperature, the electrons can be emitted from the emission. That is thermoionic. Thermoionic means it is heated. It is depends upon temperature. Thermo and means heated. We can need the metals, suppose copper, zinc, iron, anything metals. It can be some electrons are disappear from compared to initial case. We can observe the copper rod can be heated up to certain 1000 or 2000 centigrade. The electrons can be disappear or removed from the zinc or copper rod or any rod. That means it is it lost the some electrons like this. It is thermoionic. It is the electrons filament rod is arranged in the diagram, or according to diagram. The current is passing through the circuit. Current is passing through the circuit means it is can be heated up to 2500 or 3000 kelvins. Up to 2000, below 2000 or 2000, below 2500, the electrons are observe the energy from the current. In the filament, the electrons can be observed below 2500 kelvins. Above 2500 kelvins, the electrons can be ejected from the filament. This is the thermoionic emission. It is electrons emitted. Thermo means the heated. We can heat the filament or copper or zinc, any plates or any metals or filaments, tungsten, etc. The electrons are emitted up to 2500 to 3000. Below 2000, the electrons are observe the energy or heat. Then after it come to free outside, come to outside the from the metal or filament. This is the process, emission of electron in the heat process. This is called thermoionic emission. That is examples are diode. Examples are, what is examples? Diode, triode. It can become in the next last maybe semiconductor. It is diode or triode. Next to TV cathode. Cathode rays tube. That is like a picture tube. Okay, suppose we can't heat it up to certain temperature, the picture tube can be broken. That is the, and also suppose up to certain below certain temperature, the picture is coming in the television. That is that means it can be emission of electrons. The current is passing through the in the TV. That is the thermoionic emission in the television digitals. This is the process. Next one is field emission. Okay, field emission is the, we can apply the external electric field or external magnetic field anyone through the metal. The free electrons can be emitted. Suppose in this previous case, the metal having charge carriers, positive or negative charge carriers. Initially, this metal applied by external electric field, that is positive charge carriers, that is negative charge carriers. That is a metal. Yes, that is positive charge carriers. Is positive. Okay, that is electrons. Electrons positively come to this side. The positive charge carriers come to this side. That is, we can apply the external field. These are external field applied, electric field or external field, that is around 10 to the power of 8 volt per meter. This is the maximum high energy electric field applied through the metal. That is applied electric field. One plate is positive charged, another plate is negative charged. In between metal is there. We can apply the electric field around 10 to the power of 8 volt per meter, the electrons can be removed. It comes to rest position. That means outside, come to outside. It is electrons come, that is negative charge come to positive side. The positive charge carriers goes to negative side. Okay, some to rest, come to rest. After rest, the electrons can be come outside. That is the very high energy. We can apply the high energy electric field or magnetic field. Electric field or magnetic field apply the magnetic field is applied through the metal up to certain electric field. The charge carriers, negative charge carriers come to positive side, the positive charge carriers goes to negative charge carriers split side. Okay, after some time the electron come outside, that is applying energy is very high. Okay, suppose 10 to the power of 6, there is no there is stable, that means positive charge carriers and negative charge carriers will be same. Up to 10 to the power of 8 electric field, there is a free electrons. Free electrons come outside from the metal. We can apply the electric field is high electric field is applied. The electrons can be come outside. This is according to V is equal to E by D. E is equal to V by D. That is electric field is high. Electric field is high. Applied voltage is high. The electrons are come outside. Electric field is energy is high. The voltage is high. High voltage we can remove the distance is low. We want to remove the electron from the metal. That is electrons can be removed or jumped or emission. We can apply in the external electric field, high external electric field. This process is called field emission. We can apply the external field. External field, that is electric or magnetic field, may be applied high energy. We can remove the electrons from the by applying electric field, that is field emission. Electron emission, that is in the case of, that is the field emission. In this case we remove the electron from the applying field. That is second case. Third case is what? Photoelectric emission. Photoelectric emission. It is important for in this chapter. That is a photoelectric effect. It depends upon photoelectric effect. Okay, what is a photoelectric effect? That is, photo means light. You can using light, in this case field, that is means it is maybe magnetic field or electric field. We can in this field applying the electron will be emission. In the first case, thermo-ionic. Thermo means heat. The heat can be applied to the metal or any substances. The electrons can be emitted. In the case of field, means it's applied electric field. Electric field. Okay, electrons can be emitted. In the case of photoelectric emission, means photo means light. Light can be applied. The electric emission, electrons are emitted. Okay, this is the photoelectric emission. Suppose we can, initial case, this is metal having electrons, same electrons are positive charge carriers. Okay, the higher frequency or higher UV radiations in even high frequency radiation falls on a high frequency radiations at fixed radiation, that is UV, visible, micro, anyone. Okay, that is constant frequency. Light rays or radiations are falling metal surface. Observe the electrons, observe the energy. After certain time, it can be come to freely. After then the electrons can be ejected or emitted. this process in the presence of light, this is called photoelectric emission. When the incident light is falls on a metal surface, it can be observed the colloidal or collide in between the colloid or scratched in between the atoms. The electrons can be emitted from the metal surface. This type of phenomena is called photoelectric emission. That is metal having, it is depends upon frequency. Okay, that is so show here. That is current versus frequency. Up to current increases up to certain time there is no current. Up to certain time frequencies increases, okay, or voltages increases. This voltage or frequency is called threshold frequency. That means after certain time the bond is very strong. That is electron observe the energy. Okay, so suppose the electron having 2 volts, the observed energy is 2 volts. However, we can apply the 1.8 volts. Okay, the electron cannot move. That is electron having high energy compared to applied voltage. That is, we can apply the 2.2, electron can be easily jump outside. That means we can applied voltage is higher than electron voltage. That is 2.4 voltage. Okay, that is 2.4. The 2.4 voltage or 3.4 voltage, this is frequency or voltage. This is frequency or voltage is called critical or threshold voltage. Okay, when at a certain time the electron can be jump or remove the electron from the metal surface. This is the threshold frequency. It is useful to remove the electrons from the metal surface. That is in the case of zinc, cadmium, magnesium, uranium. Okay, these are in the presence of UV region. Ultraviolet, that means the ultraviolet can be used for this zinc, cadmium, magnesium elements in the presence of UV light. Suppose lithium, sodium, potassium, that is alkali ions are visible. Visible means it is a higher frequency, it is lower frequency. Okay, higher frequency means it is Zn plus 3, Zn plus 2, okay, Li plus 1. It means it's single alkali. That means in the next alkali Li plus means it can be only single alkali. It is nearest to the nucleus. That is, we can apply the high frequency. Suppose zinc Zn plus 2, Zn plus 2. That is, it is away from the nucleus. It is away from the nucleus. That is, we want to apply low frequency region. It is low frequency region, high frequency region. Okay, we can apply the visible light for lithium, sodium, potassium. Only the electrons can be emitted. When we can apply the frequency at a certain frequency, the electrons cannot move or cannot remove from the alkali metals. At a certain frequency, electrons are emitted from lithium, sodium, potassium. This frequency is called threshold frequency. That is visible region, high frequency. Frequency is higher compared to ultraviolet UV rays. Okay, that is reason is like this. In the case of lithium, Li plus 1, that is electrons attract to each other, nucleus, attraction force between nucleus and electron. In the case of zinc, it is the outermost orbital is larger. That means this attraction force is very weak in between the zinc atoms. In the case of lithium, the attraction force is very large. That's why we want to apply the high frequency radiation. That is, the metals depends upon the electron emission. It is depends upon temperature, nature of the material, and frequency of the metal. Okay, this is the explanation of photoelectric emission. Okay, thank you. Okay, now we discuss photoelectric effect. That is the photoelectric effect. Okay, from this photoelectric effect is a phenomena. It is related to the photoelectron emission. In the previous lecture, that is photoelectron emission is a phenomena of photoelectric effect. This photoelectric effect is done some experiments. For example, Hertz and Hals and Leonard, they can be observed some points. Okay, from the Hertz can be observed some observations. In the 1987, they used multi-wavelength, that means electromagnetic radiation, that is micro, radio and IR, visible, infrared, and visible, UV, X-ray, gamma ray. Okay, that is having different wavelength, different frequencies. Okay, microwave having different wavelength, different frequency. It is different frequency, that is different frequency ranges in the from electromagnetic spectrum. Okay, Hertz and observed using this different wave equations, we can use the using different suitable frequency for suitable metals like lithium, cadmium, like different metals having different colors like this. In the previous chapter, that is zinc, cadmium, magnesium, it is only for UV region. Okay, that means lithium, sodium, potassium is for only visible. That means electron flow is appear only using this type of frequency. After suppose we can using the UV light in this for lithium or alkali metals, there is no electron flow. There is no electron. The electrons are not coming to outside. In the metal, we want to eject the electron from the metal surface. Okay, using for lithium or sodium, potassium, we can using the UV light. The electrons are not ejected from the metal surface. In the inside, the electrons is there. The electrons not coming outside. Using different, that is a suitable frequency for zinc, cadmium, magnesium, or they are using only we want using the ultraviolet region, the electrons can be emitted. Okay, that is a fixed different frequency region, suitable frequency region. This is, they are observed, Hertz are observed different wavelength, different frequencies for different metals like zinc, cadmium, magnesium, like this, sodium, lithium, potassium. Okay, that is for only for visible range, that is for only for UV region. That like that is depends upon valence states or energy of outermost orbital, like this. Okay, in the case of nearest shell, okay, in the previous lesson, that is attraction force is more nearest to the nearest orbital. Suppose highest last orbital is very, attraction force is very weak, that is we want to remove the electron easily, that is attraction force is there more weak, we can remove the electron easily from the nucleus, from the metal. That is a okay, that is single phase, means we can apply the high frequency ranges. That is the reason observed by Hertz. Okay, they can using multiple of wavelength lights. Okay, suppose we can use, they are using by UV light from the lamp, arc lamp, the electrons can be ejected from the metal. When a light falls on a metal surface, the some of the electrons are metal, when some electron charge electron and positive charge as positive charge. Okay, when a light is falls on a metal surface, some of the electron absorb the energy. This energy absorb the energy. The electrons can move to the surface. There can be freely and attraction to the this last okay negative, and after certain time they goes to outside or they come to outer surroundings. They can absorb the energy. This light energy can absorb the energy by electrons. They can move and escape from the metal. This can observations are observed by the Hertz. Okay, now we can observe the Hall's and Leonard observations. They can observe with using UV rays. They can using only UV light frequency ranges. They can using only UV light region. Hertz are using different wavelength or different frequencies. Only this Leonard are using only single wavelength, that is the UV ultraviolet waves. Okay, single waves pass on a metal surface up to certain voltage, certain frequency. The electrons are ejected. Same phenomena will be appear in the by the Leonard and Hall watch. Okay, these observations can be UV rays are falls on a like this emitter, that is collector. This is a emitter, it is collector, it is closed chamber. Okay, now we can explain this. The light, some light is falls on a emitter E. The electrons are can be absorb the energy. Electrons can be ejected. These ejected electrons can be attracted, collected by the collector. Okay. This arrangement is like this. It is connected to microampere and this is connected to AC source. That is AC source, microampere circuit. How much current is passing through the current? We can observe the observations. They can observe the some current by using UV rays. Okay. Thus electron flow through the electrons are ejected. The current will be passing through the circuit. Electrons are ejected. Okay, some electrons are ejected. That means it is positive. Sorry, it is negative. It is positive like this. Okay, positive here. Positive, negative is attraction force is there. The electron can be attracted by the collector. The electron flow in the circuit. The current will be through the circuit. This type of current is called photoelectric current. Photoelectric current. This type of current in the circuit is called photoelectric current. Okay, now we want changing the polarity of this plate. That is positive initial case. Next we want changing the polarity. That we can to the potential difference is developed at between the two plates. They can be observed. The negative charge of two plates, the potential difference is developed in between the two plates. They can be observed, and also they are using different sample, different materials, zinc, cadmium. Okay, they are using different current in the circuit. They can be observed, and also they are concluded that the charged particles are emitted by the emitter. The when light is falls on a metal or emitter. Suppose there is no UV light. Okay, there is no UV light. There is no electron flow. there is no electron flow means there is no current by the circuit. Okay, there and when the current flow is depends upon only intensity, it is depends upon incident light. That is, we can using different frequency, the current will be changes. Okay, that means the electron flow, the electrons is increases, the intensity is increases. That means intensity of the intensity of electron flow, the current in the current flow in the circuit is depends upon intensity of the UV radiation. It can be observed. Okay, and also at a certain voltage, the minimum value of voltage, the current will be 0. This voltage, minimum voltage, is called threshold voltage. When we can apply the reverse potential, the electrons can be ejected. Net potential, the potential difference is developed in between the two plates. At certain voltage, the current will be 0. This type of voltage is called stopping voltage. They can be observed. Okay, now observation is completed. Now photoelectric effect. About introduction is over. Now construction. Now construction. Okay, in special case, one chamber, that is emitter, that is collector. It is connected to the AC source, and also ammeter. It is ammeter means micro amperes. It can be connected in the circuit as shown in the figure. Okay, what is the? It is a quartz window. Quartz window. What is the use of quartz? That can be, we can using the sunlight or normal light, any light. They can be filtering. Okay, light is falling through the quartz. They can be filter. We can using the different filters like red. Like this is a red filter. This is red. This is blue. This is yellow. Like this. Okay, we can this like this is a red. That means okay, red, blue, yellow. Different filters are using by the quartz filtering, and the filter light falls on a emitter. What is the duty of emitter? Emitter means it can be observe the energy from the sunlight. The electron can be ejected. These ejected electrons are attracted by the collector. What is the duty of collector means it can be collect the number of electrons from the emitted electrons. This is the duty of collector. This is the duty of emitter. Emitter means it can be observed or collected or observe the light and ejected the electron. These ejected electrons are collected by the collector. It is collector duty of collector means it can be only collect the electron flow. This phenomena and this mechanism is arranged in the closed chamber. This closed chamber is connected to the AC source. Okay, there is a positive, initially there is negative charge, the negative pole, it is positive pole. Okay, this is the construction of the photoelectric effect. That is a chamber. It is how much current is passing through the circuit. We can measure the current using micro ampere. Micro means 10 to the power of -6. That is low current in the photoelectric effect. This is the construction. Now working. Okay, now working. When a suitable or fixed frequencies are UV light, suppose we can using UV rays or UV radiation are passing through the quartz The filtering the UV rays are falls on a metal surface. The electrons can be observed the UV radiation or sunlight, that is the emitter. Emitter can be ejected electrons. Emitted electrons can be collected by collector. Okay, when collector is collected by electrons, the current flow in the circuit. This type of current is called photoelectric current. Okay, this type of current is called photoelectric current. Okay, suppose we want changing the potential difference is developed in between two plates. It is negative plate. First, initially negative, C is equal to negative, is positive means here positive, here negative. Okay, electrons, this positive plate can be attracted by electrons. Okay, this is negative place, it is positive plate. Electrons are there. The electric field is generated in between the two plates. The electric field is created or generated in between the two plates, that there is by using battery. The AC source can apply the current. The potential difference is developed. The potential is developed means due to electric field in between the two plates. Okay, the electric field or potential difference is developed in between the two plates is nothing but distance. Initially like this, last initially like this. That means at a small distance, this emitter collector. That means at a small distance, the potential difference is small. We get high intensity, number of electrons is more. That means it is a 10 electrons flow. The collector can be collect the 10 electrons. Suppose that electrons, only 9 electrons can be observed by the collector. Here 10 electrons, only observe the 6 electrons. Here 10 electrons, they can be observed the 4 electrons. That means the potential difference is developed by using electric field. The number of observing the electron flow will be decreases. Okay, this is the using we want changing the polarity of the negative potential. We can apply the negative potential. Means we can develop the potential difference in between the two plates, that is emitter and collector, like this. Short distance, intensity is high. Means current is high. Okay, the distance potential difference is decreases, current will be decreases. That means flow of electrons will be decreases with increasing the potential difference. Potential difference is nothing but distance between the two plates. Okay, now we can apply reverse potential. We can apply the reverse potential, that is C is equal to, here C is equal to negative, emitter is positive. That is second case. Okay, that is negative means electrons negative, that means repulsion in between them. The electrons can be ejected, that means the electrons are in the reverse direction. Up to certain voltage, the electrons will be stopped. Means there is no flow of electrons in the circuit. There the current will be zero. This type of current, photoelectric current, will be zero at certain potential. This potential is called stopping potential or stopping voltage. Okay, we can develop the reverse potential. That is the first. Second case, first case is C is equal to positive, emitter is equal to negative. That is first case. That is second case. Okay, in this case current will be passes there. Photoelectric current will be higher. here photoelectric current will be 0. Okay, at V0 there is no stopping voltage. Here stopping voltage is there. We want to changing the polarity of the charge carriers in the metal. Okay, the potential is developed in between the two plates. The current will be 0 at a certain voltage. This voltage is called stopping voltage. Here there is no flow of electrons in the circuit. Okay, we can apply the negative potential. There will be some work done. We can the electron flow in this direction. There is some work done. This type of work is called work is equal to QV. That is EV is equal to the kinetic energy of the particle. That is EV naught is equal to half mv square. This is the equation for the stopping potential maximum in the photoelectric effect. EV naught is equal to half mv square. This is the very important to work on potential, to develop the potential difference in between the two plates. This is the stopping voltage. Okay, now we discuss the photoelectric current with different variation of with different parameters. Suppose now first is photoelectric effect on frequency. Photoelectric current versus frequency. Okay, photoelectric current versus frequency or photoelectric variation effect of photoelectric current with frequency. Okay, suppose from this diagram at constant intensity we get different stopping potential. At 10 volts we get different colors. At 10 volts we using red, we get different stopping voltage. That stopping voltage negative potential, that is V1. Same at 10 volts green we get that negative potential is V2. Next yellow, it is at 10 volts, that is minus V3, that is V1, V2, V3. The minus V1 is what? Minus V1 red. This is red, green, yellow. Okay, different stopping voltages at certain fixed voltage, that is applied voltage. They get different stopping voltages. Suppose we can changing the 20 volts, same stopping voltage. Okay, same stopping voltage but is 20 voltage. This is input stopping 10 volts, 20 volts, 30 volts, but they red color, green color, yellow color having same stopping voltage. That is negative potential, it is positive potential. Here potential versus voltage. Okay, we want to increase the voltage, that is stopping potential. We can apply the different voltages for different frequencies. It is red having frequency having, that is nu1, nu2, nu3. It is frequency 1, frequency 2, frequency 3. This frequency relation is nu3 is greater than nu2 is greater than nu1. that is frequency ranges. Okay, there is high frequency, low frequency, higher frequency. Low frequency get lower stopping voltage, high frequency get higher stopping voltage, higher medium, that is very higher frequency having very stopping voltage. That means high frequency color or radiation having higher stopping voltage. That means frequency is proportional to the stopping voltage. From this frequency, from this diagram, frequency is proportional to the stopping voltage. Stopping voltage depends upon frequency, not depends upon intensity. Intensity changes 10 volts, 20 volts, 30 volts, but for red, green, yellow, only the stopping voltage will be same. Intensity is, that is the stopping voltage independent of the intensity. That is stopping voltage, it is depends upon only frequency. Stopping voltage depends upon frequency. That is photoelectric current not affecting on the stopping voltage. It is depends upon frequency. Okay, stopping voltage depends upon frequency. That is the only reason from this photoelectric effect versus frequency. Okay, what is the here photo at stopping voltage? The current will be 0. Here it V0, here V0. The stopping voltage, the current will be 0 at stopping voltage. The maximum kinetic energy depends upon frequency, not on the intensity. At stopping voltage, the electron can be maximum. The electron can be escape from the metal surface. Okay, this maximum kinetic energy depends upon only frequency. Stopping voltage frequency depends upon only frequency, not on intensity. That is the number of electrons depends upon intensity. Okay, the intensity here in the case of two plates, electrons are more, intensity is more. Okay, that is flow of electrons, the number of electrons, the number of photons is depends upon intensity, but intensity is not depends upon stopping voltage. The stopping voltage depends upon only frequency. The number of intensity is depends upon only intensity is proportional, but it is not intensity in the dependent of the frequency and stopping voltage. Okay, and also it is a instantaneous process. Instantaneous process means it cannot be continuous. Only in the Photoelectric effect, one positive to negative only current is there, that is photoelectric current is higher at the first case. Second case is changing the polarity, minus to negative emitter collector. First initial case, first one is second case. There is a current will be decreases. In the first case current will be increases, second case polarity will be changes. They want to remove the electron, that is potential difference developed in between the two plates. The potential electron, the photoelectric current will be increases in the first case. Next case the photoelectric current will be 0 at a certain voltage. That voltage is called stopping voltage. The voltage is proportional to the frequency of incident radiation, but not depends upon intensity. That is the reason. It is not continuous. It is a instantaneous process. Around the time period of the instantaneous process in the photoelectric effect, that is around 24/9 seconds. The instantaneous process occurring around the time, that is 24/10 seconds in the photoelectric effect. This is the first relation, photoelectric effect. What is the effect of photoelectric effect with the frequency? From this graph only frequency depends upon stopping voltage. Okay, stopping voltage not depends on intensity. Okay, it is a relation. Now second one is effect of intensity. Intensity versus photoelectric current. Photoelectric current. What is the photoelectric current? What is the effect of photoelectric current with intensity? In the previous is what is the photoelectric current with frequency. Here what is the photoelectric current with intensity? That is proportional or linear. That is intensity, that is photoelectric current. Okay, intensity, photoelectric current will increases, the intensity also increases. That means electrons are ejected in between it is collector, emitter. The electrons are increases, intensity is higher, the electrons is higher, the flow of electrons is higher. The flow of electrons is nothing but current direction. Current, photoelectric current, that current is called photoelectric current. High intensity, they gives high electrons. The high electrons means high current in the circuit. That is the relation between the two plates. That is the photoelectric current is proportional to the number of photoelectrons emitted per second. That is, number of photoelectrons is emitted by second is proportional to the intensity of the incident radiation. This is the proportionality between photoelectric current and intensity. Intensity depends upon, photoelectric depends upon intensity of the incident radiation. It is incident intensity is high, the electrons are emitted more electrons in the circuit, they get high current in the circuit. That is a proportionality. Intensity is proportional to the photoelectric current or incident radiation. Okay, now the third one is effect of potential. Potential versus photoelectric current. Photoelectric current, PEC means photoelectric current. Okay, that is a first one is photoelectric current effect with frequency. Second one is the photoelectric current with intensity. Third one is photoelectric current with potential. Okay, potential difference. The potential difference means the potential is developed in between the two plates. What is happening? Okay, that is like this. That is intensity, first one, second one, third one. Only stopping voltage is constant. At constant stopping voltage, the intensity will be changes. In the first case, that means intensity, it is not depends upon stopping voltage. That is, only stopping voltage depends upon only frequency F, that is red, blue, green. Different wavelength, different colors having different frequency. Okay, that means frequency depends upon only stopping voltage. Stopping voltage depends upon frequency. Okay, but not depends upon intensity. Okay, same the first case and third case also same. Here only potential. Potential means we can changing the intensity. The stopping voltage is constant for different intensity. From this graph, the polarity will be reversed in the second case. We want to develop the potential difference in between the two plates. The current will be decreases. rapidly decreases up to certain time. The the current will be zero in the circuit at a certain potential. That potential is called stopping voltage. This is explained in the previous photoelectric effect. Here you can apply the reverse potential. Here second case, you can apply the reverse potential. The current will be zero. That means electrons are ejected. The electrons are ejected means there is no flow of electron. The current will be zero at different intensities. The stopping voltage will be same for different intensities. Only we get stopping voltage one. Only get one stopping voltage from this equation, from this graph. That means stopping voltage is independent of the intensity. Okay, the stopping voltage, it is depends upon only potential difference is depends not particular frequency. Okay, from this graph not is depends upon intensity of the incident radiation. At particular minimum stopping voltage, at particular minimum stopping voltage, the current will be zero. That means between the two plates we can apply the reverse potential difference developed in between the two plates. The current will be zero. There is some work done. We want to repel to the electron flow. There is a sum of the work done. This type of work done is that is equal to the kinetic energy of the particle. That is of mv square is equal to E naught. That is W is equal to QV. That is EV naught. This is equal to the kinetic energy of the electron. Okay, this is the from potential developed between the two plates. Okay, this is at some constant frequency. The stopping voltage is independent of the intensity of the frequency. From this case, that means only frequencies depends upon stopping voltage. Stopping voltage not independent of the intensity. It is not independent and depends upon intensity. Independent of the intensity. Okay, now stopping voltage is proportional to frequency is greater. Greater frequency get greater stopping voltage. Okay, now third relation is over. Relation between potential versus photoelectric current. Fourth one is stopping potential versus frequency. Stopping voltage or stopping potential versus frequency. Same in the first case. Here stopping voltage is proportional to the frequency. Same here, stopping voltage versus frequency means proportional, straight line. It is first case. Second case, it is metal 1, it is metal 2, metal 1, metal B. Okay, that is a frequency. This is voltage, stopping voltage. Here at frequency, stopping voltage at stopping voltage is stopping voltage. The frequency will be maximum. From this graph, the potential varies linearly. That is proportionality. Same like first case. This frequency is proportional to the stopping voltage. This is also same. Linearity means it is proportionality relation. That is stopping voltage increases with the frequency of the incident radiation. That is, it is depends upon photosensitive material. There exists certain minimum cutoff frequency. This is the minimum cutoff frequency or stopping potential. For this is a stopping potential for metal 2, it is metal 1. like this. It is negative potential. All stopping voltage is always negative. It is a negative potential for metal 1, metal 2. That is from this graph the relation between the stopping voltage and frequency is proportional or linearity. Okay, high maximum current, that is high frequency get high stopping voltage. That means maximum kinetic energy of the photoelectrons vary with linear. Okay, what is the relation stopping voltage? That means stopping voltage up to threshold or critical voltage, there is no flow of electron. From this graph, current versus stopping voltage or frequency, up to certain voltage or frequency the current will be 0. That means current will be 0 means there is no electron in the circuit, there is no flow of electron. Okay, up to certain frequency, this like frequency, this after this frequency electron flow will be started. Electron flow will be started. That means current will be increases, potential will be increases. That is Ohm's law. I is equal to V by R will be obey Ohm's law for it, but it not obey the Ohm's law in the case of initial case. Okay, this is below threshold frequency or cutoff frequency, there is no flow of electron, there is no flow of emission of electron from the metal surface. This frequency is called threshold frequency. This frequency is called nu naught. This nu naught, this nu naught is the same. Okay, this nu naught. Okay, it is depends upon different metals having different frequencies. Stopping frequencies or cutoff frequencies or threshold frequencies. Okay, this obey. This is more for selenium. Selenium having more sensitive than copper and zinc because they having get more threshold frequency. Okay, thank you. That is in photoelectric is a instantaneous process. Okay, that is it is not a continue process. Thank you.